Hello everyone, welcome to my channel. Let's solve the problem add one row to tree. So you can pause the video and read this problem statement by yourself and understand. So let me explain you what is the problem is. So in this problem we are given a three things. One is the root node of our tree, which is like one of root of our binary tree, and a value d, which is representing the depth d, and it is a one way. So the root node here has a depth d is 1, and this row, this level has 2, and this is 3. And another thing, v is a value which is like we have to create a row of value nodes with value v and introduce a row at after the depth d minus 1. So after depth d minus 1. So let's say for example, if our d is 3, so if d is 3, then at d is equal to 2. So at this, after this, so this is d is equal to 1, this is second row, d is equal to 2. So after this we have to introduce somewhere here our new row of the nodes with value is b. So how it will be? So what we can do, we have to introduce like new node over here with value v, and similarly new node over here value v, and new node over here value v, and another node, new node over here value v. So we have to create a new node, two new nodes for every left and right child of this node at non null node. So this is 2. So we will create 2 node over here, and after that how we need to join further the remaining left subtree. So as you can see here, 3 is a left subtree, like after 3 there might be more nodes, let's say 4, 5, and it's kind of a subtree. So we will take whole subtree as it is from the left of 2 and assign this to the our new node of v. So this is new node. So finally if I write, this tree looks like 4, then we will have here 2, then after 2 we will introduce a new node v at left and v on the right, then the left of v will be the left subtree of 2, which is starting from 3, like this. There will be more for the node if there, and similarly the right of right node will be the right subtree of 2, which is from the 1. So like this. Similarly from root we have 6 here, and after 6 we will introduce 2 new node left of and right v with value v, and then we will assign the left subtree of 6 to the left of left, which is value from 5, and there is no right subtree of 6. So this is as it is null. So this is how we introduce a row of with node values v at a level d, so after the d minus 1. So this is what the problem we have to solve. So in case there is a special case when d is 1, in that case, as we know as per the problem, the root node as level 1, so we don't have any zeros level here. So what we need to do, we need to create a new node over here with value v, and this will be our new root of the tree, and we have to assign the old root to the as a left child of this node. It is given over here in this problem. So in case if it is d is 1, means there is no depth d minus 1 at all, then we have to create the new row origin and assign the root of original tree as the left subtree. So this is what we have to handle this as a separate case. Otherwise we can write a generic algorithm for solving this problem. So how we can solve the tree problem? As you know, we can either use DFS or BFS traversal. So what like if you know can solve by one traversal, the other is kind of just changing the structures and modifying little bit. So I am explaining this how we can solve this problem using the level order traversal or the BFS traversal. So in BFS traversal we have to first reach starting from the root node at the level d minus 1. Once we reach d minus 1 level, in that case after that we introduce the new nodes at a new level of new nodes and then adjust as per the problem. So first of all we have to reach. So for using BFS or level order traversal, we always use a queue. So base case we can handle before itself. If d is 1, then just create new node and return. I will explain more in code when we implement. So for other rest of the case, we will add the root node first into our queue, and then we run a while loop while our d while. So we can either use new depth variable, or I am just using if our d decrement by it is greater than 1. If it is greater than 1, then iterate this tree, process tree level by level. So, first level we will fetch the 4 and from the queue, and then check if it has left or right subtree. Yes, left or right child, then we will add like 2 into the queue and 6 into queue, and after processing the level we decrease d by 1. Like initially we started with d decrease 1 and then we keep decreasing d by 1. So, once we reach, so for let us say for d is equal to 3, so initially we will add 4, then we process one more level here. So, 2 and 4 6 will be in our queue, and after that d will become 1, which is not greater than 1. So, this will stop over here. Then we will pick the nodes from our queue. So, we will write another while queue has node here. So, I am just explaining so that you can pause the video and implement it yourself as well. So, first we will fetch the node from the queue, like let us say node is node, and then first we will save its left subtree reference into a variable LST and the right subtree node dot right into the right subtree reference, and after that we create 2 new nodes. So, this is very important, you have to create 2 new nodes, it's because each node should have different references in the heap. So, we will create and assign node dot left and right to our original node, which we are pulled from the queue. Once we did, after that we update this new node, the left side we are assigning, the left of this will be the LST and right there will be nothing, it's null. And similarly for the right sub node we will assign the right as a right subtree. This is the, once you do this we will get the answer. So, you can pause the video and try to implement the code over yourself. So, let us start the implementation. For the implementation, first we will handle the case where d is 1. In that case, we just write tree node new root, this will be tree node from the value v. Once we done, then we update new root dot left will be the original root and then return new root as the answer. This is the case we handle first. Now, after that we will create a queue of tree node, queue new linked list, we initialize from linked list, add the root into the queue. Now, after that while minus d is greater than 1, then keep processing this tree, iterate tree level by level. So, for level by level we can introduce size variable from queue dot size, and then while size minus greater than 0. If you are not aware how does full level order, I have also posted separate video on that, you can check out that as well. So, after that we fetch the node tree node from queue dot poll and check if node dot left is not null, then add into the queue dot add node dot left. Similarly, check for the right child, if node dot right is not null, add into the queue dot add node dot right. Once we reach on that level d minus 1, after that we just process while queue dot size is greater than 0, while our queue has node, then we will fetch this node as it is node. After that we save the reference for LST less subtree, which is LST node dot left, similarly RST, which is node dot right. Once we save the reference, then we assign node dot left the new tree node from with the value v, and similarly we will add node dot right as a new node. Not after that node dot left is LST, assign back, then node dot right is RST. So, this is what the implementation is done. Now, we will return the original root as a root of our updated tree. So, let us compile this code and see if compilation is happening. Compilation is happening and we are getting expected answer. Let us try some other custom test cases. So, here in the same tree d is 1, d is 3 and now d is this with some other value, that is it. So, let us compile all the custom test cases with different d and v values. So, as you can see there is no diff, we are getting expected answer. Let us submit this code and see if it gets accepted. So it got accepted. So what is the time complexity of this solution? So the time complexity in worst case, we may process all the nodes in our tree, so which is O of n, and the space complexity in worst case we will have the width of our tree, whatever the max width of our tree in the queue, that many. So in general we can say that is O of x, and x is the width of our tree. So if you like this solution, hit the like button and subscribe to my channel. For the DFS solution, you can just call the recursive method, and this will be the one base case here in main method you can put. After that you can call the DFS recursive helper method, and there you can also put this condition check. Once you reach on that case, when d is this, like you can keep another extra variable depth, and once depth is d minus 1, you can create these nodes basically. Otherwise you can call left and right subtree with the decrementing or incrementing the depth. So that's it.